Hi everyone, welcome back to our channel. Today we are going to perform this MATLAB simulation of admittance parameter, which is also called by parameters. Here you can see here the same network we need to construct. So here you are going to have a T network. This is an T network. So this is 820 ohms, this is 510 ohm and 2000 ohm, and we need to perform short circuit. When you perform short circuit, then we are going to get Y11 as well as Y21. Okay, so where this called transfer admittance, where this is called input driving point admittance. Okay, so similarly, we have to, for the same circuit, input should be short circuited, and we have to find out the values of I1 as well as V2 as well as I2 and V2. Now let's try to construct this circuit diagram. Okay, so let's try to see here what is the process of constructing. Okay, so here you can see here at the top you have a library browser. So first let's try to, here you have the how to add the file. Okay, so or you can directly go to file, just click on new, click on blank. Okay, then automatically a blank simulation file is opened. Okay, let's try to keep side by side and let's try to work out. Okay, so minimize this and keep it as a side, and now let us try to see here how to simulate this one. Okay, so keep this in the next half. So one parameter by parameter will drag and will substitute. Okay. So at the top I already told, here we have library browser. Click on the library browser and check the elements. What you require is a voltage source and three resistors, one ammeter and voltmeter. Okay. So here it will be available. Scroll it down and here you can see here. So here you have Simscape. Okay. So identify where the Simscape is there. In Simscape, so now we are at go to electrical. In electrical, go to fundamental, specialized power system. In specialized power system, go to fundamental blocks. We require voltage source. So what kind of voltage source we require is DC. Just drag and place. Okay. So now DC source is available. Next you require elements. Okay. So drag series RLC branch and place it here. Okay, and then you require measuring components. The measuring components are voltmeter and ammeter. Drag the ammeter as well as drag the voltmeter. That's all. Okay, so now let us try to see here what remaining components we require step by step, and we require one multiplier. So here you can see here in the library you can go and you can go to mathematical operations. Okay, mathematical operations, click on mathematical operation, then you're going to get multiply and divide. Keep it in the down. Okay, now let us try to design our circuit by seeing this circuit. Okay, so now here you can see here this is the voltage source and this is the voltmeter and this is RLs. Here you can see here we have an T network. Okay, so double click this resistor and just represent this element as R and click on apply. Okay, and click on OK. Okay, then you're going to get this resistor. Okay, and now here you can see here this is one series branch. Just copy it by using Ctrl C and paste here, which is nothing but Ctrl V, and one more also Ctrl V. Hold this resistor, click on right options and just use rotate and flip, just one side, I mean 90 degrees rotation. Okay, so keep it all this aside. Now from the DC source you connect to this resistor, and from this resistor you connect here, and this also you short circuit. And now let us try to see here. Okay, so here you can see here output I have to short circuit. So we have been short circuited the output. So in order to perform Y11 we require I1 by V1. Okay, so I1 I require, this is nothing but I1. Remove this branch and inject the value of I1. Okay, so from positive connect to the ammeter and from negative connect to the ammeter. So to see the output, let's once again go to the library and scroll it down. Let's try to come to sinks. In the sink we have display, and drag the display and place it here and just connect to the display. Okay, so that's how to connect. Okay, so we require the parameters of I1 and V1. Okay, so this V1 also if you have doubt you can directly connect to the voltmeter. Okay, so just connect the positive to positive and negative to negative. So you see here, if it's a proper connection, it will be shown in a black color line, or if it's an improper connection, then it will show in red color line. Okay. Here also I want to see the output. Just use Control C and just use Control V. And here you can see here at the top we have a GUI. Okay. So in order to have it, go to library. In order to run this, okay, we require GUI. Let's try to go to fundamental blocks. In the fundamental blocks, you'll be having Power GUI. Drag and place this block here at the top of the diagram. Okay. So now let's try to define the parameters one by one. Okay. So here we are giving an voltage of 30 volts. Okay. So represent this also as a voltage of 30 volts. Just click apply. Okay. So here you can drag it and you can make the diagram more beautiful also. So if you want to write any comment, you can write down MATLAB simulation of Y pyramid. Just click here, write down just MATLAB simulation of Y parameters. Just add MATLAB simulation to annotation. Just write and move this here and this to downward direction. Okay. So double click on it. So double click on this parameter. Just increase the size to some 18 or the size whatever you require, 24, and go for the color of red, and it will display here. And if you want more clarity, you can go with the bold colors. So this is what how to write down the title. And here you can see here you require a resistance of 820 ohms. So double click on this and insert the resistance as 820 ohms. Theoretical calculation also performed is available in our channel. You can watch from there. And this is 510 ohm. So go double click here and write down it as 510 ohm. Just click on apply as well as OK. And double click this 2000 ohm resistor. Here also you have 2000 ohm resistor. Double click on it, then you're going to enter it as 2000 ohm resistor. Okay. Now coming to which parameter we need to link. Okay. So just connect the scopes and take as soon as you run it, you're going to get some parameters indicating the voltage is 30 and the current is 0.024. So you can use a multiplier. So how to use the multiplier is just go to library and click on general usage block. You'll be having gain. So this is current, but I want to understand in more detail in milliamperes. Remove this link and insert this gain here and just drag it. Okay. And enter the gain value as 1000. Okay. So as soon as you write into 1000, automatically it will be converted into milliamperes. Therefore here I can write down, just click on this display and write down it as I1 in milliamperes. That's all. Okay. So here output is short. So how is this it is short circuited? Let us try to see here. So actually we have the equations of y parameters is I1 is equal to, okay, so I1 is equal to y11 v1 plus y12 v2 is the first equation, and second equation is I2 is equal to y21 v1 plus y22 v2. So now in order to perform it, let's try to make output as short circuited. Make V2 is equal to 0. V2 is 0 means output port is short circuited. So when output is short circuited, this term and this term will become 0. Then you are going to get y11 is equal to I1 by V1. Okay, and here also V2 is 0. Then you are going to get y21 is equal to I2 by V1. Okay, so this is what you are going to get. Output is short circuited. We require ammeter in the input port and ammeter in the output port and V1 also. Okay, so for this only we have been inserted these meters. So coming to the original simulation, you require V1 as well as V2 also. Okay, so here this already short circuited. Okay. So check out the diagram. Here you require one more ammeter. so where you can directly analyze the things. Hope it is visible now. So here require one more ammeter. Just copy this ammeter, Control C, just Control C and Control V here. We need to inject this. Just remove this link and connect an ammeter to this one, and from negative you connect to here, and let's try to keep an um, measurement of current. Just place a block and drag it, and this is nothing but output. You're, so you're going to get the current I2 in milliamperes. And now if you want to keep this value, just click on this series branch and you can write this value is 820 ohms. This is 820 ohms. And now we require the relation of I1 by V1. Okay, so this is I1 and this is V1. Okay, if you want you can write down at the bottom, this is the value of V1. Okay, so now we require I1 by V1. So for this we are having an summer. So in this I1 by V1, so just connect I1. Okay, so I1 by V1, so V1 is nothing but this value, connect here. Okay, in order to see the output, just use Control C, Control V, paste here, and this will give the value of y11. Okay, so y11 is equal to I1 divided by V1. This is what we had also done here. So just try, just run it, you can get the answer. So here you got, when you done it, you're going to get 0.00085 in MOS. So one part is completed. Coming to the second part, just copy the same block. Here you see, here you can parallelly also you can read. Okay, so just try to slide it up and just try to keep one more block. And here we require, just copy it, Control C and Control V here, just connect it. So what are the two parameters we are going to get here is I1 by V1 is completed, and we are going to get I2 by V1. It's nothing but Y21. Okay, so this is nothing but Y21. So Y21 is equal to I2 divided by V1. Okay, so I2 divided by V1, where this is nothing but transfer admittance. So here you require I2. So where is I2 here? So this is the value of I2. So I2 divided by V1. So here already you are having V1. Okay, so connect this to V1. Okay, or here you can see here at the bottom also you are having V1. So directly connect to it. Okay, just run the simulation. Okay, therefore you are going to get 0.00167. So here what I have done is output is short circuited. Here you can write down output V2 is equal to 0, that is short circuited output. Same circuit you have to draw it and you can just run it. So this is how you can do a simulation of your own, and you can verify whether the admittance parameters are same or not. Okay, so as per my analysis, here also you can see here you are getting 0.00814, and here also you are going to get 0.0167. Okay, now coming to the next step, second step is, here we have been short circuited the output port. Okay, so now we will short circuit input port. Let's try to make V1 is equal to 0, which is nothing but input port is short circuited. So input port is short circuited means V1 is 0. When V1 is 0, therefore you are going to get these two values, which is nothing but Y12 is equal to I1 divided by V2. Y22 is equal to I2 divided by V2. Okay, so these are the two values you are going to get. Okay, so first we need to perform V1 is equal to 0 and we have to get I1 by V2. See here, you need to measure output voltage and 2 ammeter same. Okay, so you can see here the same diagram I am taking. Just to copy the sources, just first copy the elements. Okay, control C, control V. Okay, this is one element, and control C, control V. Okay, so what is the value of this one is 510. Okay, you can write down here 510. 510 ohms, and this also you just copy it and paste here, and you require I1 and I2 currents. This current you directly connect it. So here, here output we have been short circuited. Okay, so output V2 equal to 0 is short circuited. And just click on this annotation, you will be getting it. So here we have to apply the voltage at output side. Just copy it, control C, control V, and just connect to the source. And here also you require the I1 as well as I2. Here you can see here you require I1 current and I2 current. You require 2 ammeters to be connected. So let's try to copy this control C, keep the ammeter here, and keep the ammeter in this branch also. So now current is flowing in this direction, so current is entering is positive. Just rotate it. So just go to right click and just find rotate and flip, rotate clockwise. Okay, it's not suitable. Again, rotate and flip, just rotate clockwise. Now it is suitable. Just connect the positive to positive and connect negative to negative, and output of this you connect to ammeter, and output of this resistor you connect to here, and output of this you connect to here, and here also current will be entering. Okay, just use a control R button. Just connect positive to positive, connect negative to negative, and here you are going to get the values. Just copy it, copy this scope as control C and paste here, and here also you paste here. So this will give the current I2. So this is current I2 in amperes. Okay, so for this theoretical calculations is also done, you can verify there. So here also you are going to get, this is we are measuring with respect to I2 in milliamperes, which is nothing but output. So this will be acting as an I1 in milliamperes. So already we had given all the parameters. We need to see, check out the voltage 30. Okay, if you want to check this voltage also, you can connect an voltmeter, but actually not required. You just connect a positive to positive and negative to negative. This will give the voltage, which is nothing but V2 voltage. Just copy it, control C and paste here, and this will give the, just run it once, you can understand what are the errors you are going to get. Nothing errors are there. So here you are going to get a voltage at input side, which is nothing but V2 equal to 0, and here you are going to get the current I1 and I2. Okay, so now let's try to construct a Y12. Okay, so Y12, if you require, here you can have a multiplier. Just to copy this multiplier, control C, control V. Okay, so you can see here, and let's try to keep this scope, control C, control V, and here we are going to find out Y22. Okay, so Y, just edit it. Y22 is nothing but I2 by V2. Okay, so I2 by V2 we require, where is I2? So this is nothing but I2. Okay, so connect I2 to, if the connection is wrong, it will show in red color. If the connection is good, it will show in black color. Okay, so the connection is perfect, which is nothing but I2, and this is nothing but V2. So V2 is nothing but this value. Just drag it out as per your need and connect to here. So with this it is completed, and next you require Y12. Okay, just to copy it, control C, control. So if you want to move this type of a clumsy diagram, very simple, just draw the complete diagram, just move it down, and just use your mouse and just hold on the in one item and drag it down, then you can understand. So here you are going to calculate y22. Just copy this block also, copy and paste here. Now we need to calculate I1 by V2. So where is I1? This is nothing but the value of I1. So initially you are going to have I1, V2. V2 is already here. Okay. So the denominator is same. Just connect directly to the denominator, and this will give the value of the scope. Just copy it and paste here, and this is the value of y12. Y12 is equal to I1 divided by V2. Just connect the scope here and just run it. Very simple, once you do the simulation you can understand the things better. So therefore you are going to get y22 value is 0.00004, which is nothing but mos, and y12 is equal to 0.0165. If you want to write down the comment, here you can write down the comment. Okay. So here, if you are unable to understand, you can move this also to here. In order to make you clear, I'm removing these sources. To just use a Control R and just connect it. Why? Because I have to show you how the short circuit is there. Now this is short circuited, and you need to write down the current. Just connect the current here, and here you require I1. Connect I1 to I1. That's it. Okay. So if you have any doubts in the connection, we can verify it. Very simple. Just connect I1 by V2 and connect I2 by V2. And here we can make a one comment, which is nothing but input port is short circuited. That is V1 is equal to 0. Just click on add input as notation, then you'll be getting. Okay. So you can see here successfully we had find y11, y21 as well as y12 as well as y22. The formula behind this one is like this. So initially output you have to short circuit, we have to find out I1 by V1 and I2 by V1, and next step we have to make V1 is equal to 0, then you have to find out y12 as well as y22. So this is the process of doing the MATLAB simulation. Hope you are able to understand the method, and all these are already available in my MATLAB YouTube channel. You can refer the theoretical calculation. If you feel my explanation is good and simulation is good, please like to my video and share with your friends, those who are studying this lab. And if you have any doubts, let me know in comment section. And if you are watching my channel for the first time, subscribe to my channel with the name KV Tulasira. So kindly encourage this sort of free channels for the development of students and faculty. So here I have been done the output simulation in 3 variants. First, you will be having theoretical calculations. Theoretical calculations followed by practical hardware calculation, and this is the simulation, MATLAB simulation validation of results. So this is by using computer. So if you do a problem in these 3 variants, there's no scope that will not there's no scope that all the things will be covered, and you'll be very clear how to solve the problem theoretical, how to solve the problem practical by using hardware, and how to verify the result using simulation. Okay, whatever is not possible by hardware, we can check out with simulation. Thank you for watching. We'll meet in another beautiful video. Thank you.